So hi everybody, welcome to this first video on terpenoids. Terpenoids are a class of naturally occurring organic chemicals. And they are the largest class of plant secondary metabolites. So they represent almost up to 60% of all the known natural products. So the most natural terpenoid hydrocarbons have the molecular formula C5H8N. Okay, and the value of N is used as the basis of classification. So these terpenoids have been classified based on the value of N. So let us see how they are. What are the names that have been given? So based on the number of carbon atoms, and the class. First up, if the number of carbon atoms are 10, okay, so these are called monoterpenoids. So these have the molecular formula C10H16. Their hydrocarbon skeleton molecular formula happens to be C10H10. If they are 15, so they are called sesquiterpenoids, and these are C15H24. They are 20. They have diterpenoids, C20H32. If they are 25, they are called sesterterpenoids. So they are C25H40. The carbon atoms are 30. They are called triterpenoids. So they happen to be C30 and H48. They are 30. I think if they are 40, the carbon atoms are 40. They are called tetraterpenoids. So they are C40, H64, and if they are greater than 40, if the carbon atoms are greater than 40, they are called polyterpenoids. Okay, so they have a general formula C5H8N. So N happens to be more than 8. Okay, now what are the uses of terpenoids? So simple mono and sesquiterpenoids are the chief constituents of essential oils. So these essential oils have been used in perfume industry from the earliest times. Tetraterpenoids form a group of compounds called as carotenoids. So these terpenoids have been found useful in prevention and therapy of several diseases including cancer. These also have antimicrobial, antifungal, antiparasitic, antiviral, anti-allergic and anti-inflammatory properties. Of course, rubber is the most important polyterpenoid and we all know its how important and essential it is. The thermal decomposition of almost all terpenoids use isoprene as one of the products. So the structure of isoprene is C5H8, and the skeleton structures of all naturally terpenoids may be built up can be built up from isoprene units. So this is known as isoprene rule. This is called isoprene rule. So let us see how. So any natural terpenoids can be broken down into simplest. Can be broken down in this way. Right? If it is acyclic structure, one of if you see here, so how this can be broken 1, 2, 3, 4. So this they may be connected in this way, and if it is a cyclic structure, so this is your acyclic structure and this is your p cymene structure. So most see here how they can be divided. They can always be divided in terms of C5H8 carbon skeleton or carbon hydrogen skeleton. Okay. There is something called as special isoprene rule, which tells you that when the isoprene units are joined head to tail, when isoprene units are joined head to tail sequentially. What is the head? The head being the branched end of the isoprene. So this is called a special isoprene tool. So which is a branched end. See here. So this becomes your head, and this becomes your tail. So this divisibility into isoprene units and their head to tail union is called as this. Then it is called as special isoprene.